So Kendra is a recent interdisciplinary PhD graduate from UMaine, which is great. And her research, well, with mathematics is a key part of that. So this is yet another example of how math is way cooler than most people get a chance to experience. Kendra's research centers on developing cutting-edge computational techniques for detecting precancerous lesions on mammograms. Her work has resulted in co-inventorship of 2 US-issued, 1 EU-issued, and 1 EU-pending patent. Just today, in the Bangor Daily News, was an article that Kendra won the regional Top Gun pitch Thursday night in Holton.
Thank you.
And she is one of 2 counties, so I failed to neglect, she's up in Aroostook County. I'm going to say this, I know there's at least one person from Portland here, so I appreciate you being here, Dave. I'm glad that you recognize that the highway keeps going north, past Freeport, even past Augusta. Kendra's really bringing it in Aroostook, so I'm just going to let that sit there. She is competing next week, right? For the $25,000 state Top Gun showcase pitch event. What you are going to see here tonight is not that pitch, so it will be even better.
Exactly.
The one thing I asked all of my speakers to do is to give me something that's pop culture science related so that you get a chance to understand that everyone here is just as, I was going to say just as wackadoodle, but that's not fair. Even though they're deeply engaged in science and often have a vocabulary in that field that is hard to understand, they have just as many passions and likes as the rest of us who our passions might be sports or theater or trivia of all kinds or fill in the blank. So Kendra's pop culture favorite, when she told me this in March, so if it's changed, I'm really sorry, is my octopus teacher.
Yes.
It's all yours. Let me get you set up.
Thank you. Okay, perfect. That's fair. Okay. So hello, everyone. I'm Kendra Batchelder, and I'm the co-founder and CEO of WAVED Medical, and I'm really excited to be here with all of you today to discuss how we're taking an interdisciplinary approach to research to discover new biomarkers for breast cancer. So breast cancer is the most common cancer worldwide. Now, breast cancer can either be non-invasive or invasive. So invasive breast cancer means that the cancer has started to spread to the surrounding tissue and possibly to other parts of the body as well, which can make it more challenging to treat. Just this year, there was a new study that came out that discovered that breast cancer incident rates are increasing 15 times faster in women under the age of 50 than they were prior to 2016. That makes screening mammography even more important than it already was. Unfortunately, up to 30% of breast cancer cases are still being missed on screening mammography. So that's where our team of image analysis experts and also biomedical engineers thought that we could come in and make a difference. So we have a strong background in enhancing medical imaging. So we thought that if we worked closely with clinicians such as radiologists, we would be able to enhance these images and detect breast cancer earlier. So the project started with us collaborating with a group of radiologists. And what we found is that one of the major problems with screening mammography is what's called dense breast tissue. So dense breast tissue shows up as white on a mammogram, which is unfortunately the exact same appearance of a cancer on a mammogram. Therefore, radiologists are challenged with the task of identifying a white cancer inside an image full of white in over 50% of the women that are screened each year. On top of that, 70% of all breast cancer cases occur in women with dense breast. So after collaborating and understanding that this is a very significant problem, we decided this is where our team could come in and work on enhancing these scans that are already collected in the clinics. But before we started to throw a bunch of different metrics and a bunch of different methods at the images, we decided to ask biologists what they knew about breast density and the process of tumor invasion. Well, it turns out that biologists know a lot, but what was very beneficial for us was to understand the process and how it relates to organization. So when there's no tumor present, the cells and the microenvironment are very organized. So the epithelial cells are very lined up and organized like a biologist would want. And the microenvironment, which consists of collagen and makes up the dense breast tissue, is also very organized. However, as a tumor begins to appear, this organization starts to be lost. So the cancer cells don't line up as nicely, the collagen changes, and things become disorganized. And as the cancer progresses and becomes invasive, it becomes even more disorganized. So as image analysis experts, we found that we are very good at quantifying organization in images using what's called the Hurst exponent. So the Hurst exponent tells us how organized spatial structures are. And so we applied this technique to mammography, and we found that we were able to segment dense breast tissue for radiologists, so that's shown in purple, and then also segment areas of fatty tissue. So this was already very great for us because we could identify the woman most likely to progress to invasive disease. But one thing that always stayed with us is that not all women with dense breasts go on to develop breast cancer. So what we were able to do, because we were using this measurement that gave us spatial structure, is we were able to actually take dense breast tissue and segment it into two different types. So one being areas of at-risk dense breast tissue, and then other regions that show spatial structure is still held. So what we were able to do was to infer that these at-risk dense breast tissues is associated with that disorganization happening at the cellular level. So we completed several studies, and so these groups had patients with mammograms that had a cancer, and then we also had another group of patients that did not have cancer in their images. And what we found is that patients that had cancer had high levels of at-risk dense breast tissue compared to the patients that didn't. But don't forget that this disorganization appears before the tumor becomes invasive. So what we did is we looked at patients' history before the cancer was detected. So here are two patients, and you can see that patient B has high levels of at-risk dense breast tissue. If we follow these patients set for 7 years, the patient that had high levels of at-risk dense breast tissue ended up developing invasive breast cancer. Thank you.
If you have questions, please come on up. You're going to sit there?
Well, real quick, you started off by saying that you saw an increase in breast cancer, and I was just curious if you knew why that was, or was there any research that might suggest why?
Yeah, there's a lot of new research coming out, and it's looking more at lifestyle, so such as diet and different products that are being used, such as perfume and deodorant. And there's actually one recent study that came out just this year that linked, I think it was around, I don't remember, 700, 900 different chemicals to different types of cancers as well. So really looking at environmental and lifestyle choices.
Hi, I'm wondering if the idea of if it's happening yet where they're looking at taking genetic testing, which some people use to have preventative care, such as mastectomies, mm-hmm. and combining it with this, and whether you get a more accurate idea of whether cancer could come.
Yes, that's one of the things we'd like to explore. So family history and genetics do qualify women as being high risk, and then they get preventive care options such as additional imaging or mastectomies. One limitation of genetics and family history is that only 10% of all diagnosed breast cancer cases can be linked to a known genetic mutation. And so overall, 50% of all diagnosed breast cancer cases do not have any known identifiable risk factor. So combining those risk factors with our risk factor of at-risk dense breast tissue has the potential to improve that even further.
And I just want to say I'm a breast cancer survivor, so thank you for your work.
So I see it says WAVE add-on software. Does that mean that you're going to be able to add this software into existing systems for mammograms at this point?
Yeah, so one of the main goal of WAVED Medical is to take this technology and integrate it into the clinics. That way when a woman comes in and gets a mammogram, it would also flow through our software. We could identify the at-risk dense breast tissue and predict if she'll develop breast cancer over the next 3 years, and then receive the preventative care.
Nice.
Thank you, Kendra.